you. Uh, so data mining can be divided up into two types of tasks. One is sort of a more traditional type of task, which is having to do with taking some input data and then making some sort of prediction based on the input. So that's a standard, scientific procedure to do. And the other task in data mining is called clustering. So I'm going to talk a little bit right now about what clustering is. So let me open this up. Did I do this before? Clustering, no. Okay. So let me give you some example of where you might use this first of all. Um, let's suppose that you are interested in whiskies from Scotland. Okay, so in Scotland, let's suppose that they have like, I don't know how many they have, but let's suppose they have 20,000 different whiskeys there. That's probably more than they have. But let's suppose that they had 20,000 different whiskeys in Scotland. So we have all these different whiskeys, right? Let's just say this is the set of all the whiskeys. And with each whiskey, we could, let's say whiskey 1, whiskey 2, and so on, whiskey 1000, right? And so on. We could measure lots of different aspects of the whiskeys. For example, we could talk about their price. So the first one costs, I'll do it in dollars, $30, and the second one costs $12, and so on. Okay, besides that, we could measure lots of other things like the alcohol content. So let's say alcohol content. So this might be like 50%, and this one might be 55%, and so on, right? We can do that. And we could talk about the color, because some people care about the color of the whiskey. So you could have color, and you could describe it in various ways. You might actually describe the color like light brown or dark brown or whatever, light brown and medium brown and so on. You could talk about the color. You could talk about, I don't know, the bitterness. I don't know much about whiskey because I don't like whiskey. But you could talk about maybe the bitterness. Okay, and you might have some kind of measure of bitterness. You could talk about the sweetness. I suppose whiskeys aren't very sweet, but if you're talking about wines, you might talk about the sweetness. Okay, or you could come up with lots of different measures or variables for thinking about these whiskeys. Okay, let's suppose you had 20 of them. Okay, so now, like before, I said suppose we had 20,000 whiskeys. So that's too much, right? That's too much to sort of think about, too much to consider. So one thing you might like to do is to group these whiskeys into groups that are similar. Right? That would be a kind of nice thing to do. So you could take, oh, here's a group of whiskeys that are similar, here's another group that are similar, here's another group that are similar, here's another group that are similar, and then you might say, okay, instead of having to try all 20,000 whiskeys, you'd say, okay, I just broke it up into 10 different groups, and now I'll just try one from each group, and that'll kind of give me an idea of what I like, and then if I like this group, then maybe I'll, focus on that group, or something like that. Right? So breaking these things up into groups that are similar could be interesting and useful. And in data mining, that procedure is called clustering or grouping. Right? So how do we group them? What does it mean? How do we say these are similar? What does it mean to say these are similar, these are similar, these are similar? What does that mean? Well, it means similar according to these variables or these aspects, right? So maybe similar according to price and taste and so on, right? So we're kind of interested, so we're going to use these variables to sort of measure how close um, the whiskeys are. Okay? So that's the idea behind clustering. Okay? So now I'm going to show you, so there are a number of different sort of computer algorithms for doing this kind of clustering, and I'm going to show you one of them right now. Okay? Now, in this example, since I'm going to try and picture it, I'm going to try and picture it according to the variables. You know, if we're trying to show something in 2 dimensions, right, on the screen, right? Basically, you can only have two variables, a variable here x1 and a variable here x2, right? You can only have 2 variables. So I might like do price versus alcoholic content, but I can't do more. I can't show you more than that, right? The idea is going to be the same regardless of whether I can show it to you in 2 dimensions or not. But in the demonstration, I'm only going to be talking about 2 dimensions. But it extends easily to any number of dimensions or any number of variables. So let's look at it. How do I do this here? Okay, so here are the 2 dimensions. So I have, say, for example, a bunch of whiskeys, or not necessarily a bunch of whiskeys, but just a bunch of data, and each data point here, this one, this one, this one, this one, they all have an x value and a y value, right? For example, this one here has, if this is the x-axis, this has a low x value and also a low y value, right? Whereas this one up here has what? Kind of a high, or this one, say here, has a kind of high x value, but not such a high y value. Okay, so this is our data, and it's in 2 dimensions. And what we want to do is we want to find groups of data that are similar. Okay, so here's how we're going to do it. All right, well, so maybe this is going to be one group. We haven't seen where this comes from yet, but maybe this is going to be one group, and maybe that's going to be another group, and maybe that's going to be another group. Okay, but let's see how we arrive at these groups. Okay, so here we have the data again, and the way this algorithm works is first you pick 3 initial cluster centers. So what we're going to do is we're going to group this, we're going to choose to group this into 3 groups. So you have to set that at the beginning. Okay? So, so in order to do that, the first thing you want to do is pick 3 initial group centers or cluster centers. And you pick them randomly. It's kind of strange, but you pick them randomly. So you can put a dot here and another dot here and another dot here, or put it anywhere. Okay, so we're going to do that. Okay, so we pick 3 random centers for our groups. Okay, what's the next step? Assign each point to the closest cluster center. So in other words, this dot here, which center is it closest to? K1, K2, or K3? It's obviously closest to K2, so we'll assign it to K2's cluster. Okay, whereas this one here is closest to which? It's closest to K1, so we'll assign it to this cluster. So you can see how the data has been assigned to different groups. Okay, but this is kind of random at this point. Let me just fix this for a second. Pointer options. Okay, so what we do next is, anybody, I don't think anybody can guess. Can anybody guess what we might do next? Collect them? How do you collect them? All right, well, is this really the center of this group? It doesn't really look like the center, does it? Right, it doesn't really look like the center. Now, how could I define the center of these green dots? Well, I could take, okay, this dot has an x-coordinate, right? This dot has an x-coordinate, right? This dot has an x-coordinate. They all have x-coordinates, right? So what could I do? I could take all those x coordinates and find their average, right? So it's going to be somewhere like around here, right? Like around here, right? Something like that. And then each of these dots also has what? A y coordinate, right? So what could I do? I could take all those y coordinates and find their average, right? So that's going to be somewhere around like here, right? Okay? So that's going to define the center of this cluster. Okay? So that's so now move each. So what I've done is I'm going to take this one and move it to the actual center of the cluster. I'm going to take this one and move it to the actual center of this cluster. I'm going to take this one and move it to the actual center of this cluster. Okay? Does that make sense? Okay, after I do that, what am I going to do? After I do that, what am I going to do? Anybody have a suggestion? Any idea? Okay, so this K1 is now going to be over here, right? What do you think about this dot now? It's probably going to, what, be closer to this K2 than it is to this K1, right? Does everyone, I mean, it might not be true, but it might be true, right? So what we want to do is recalculate which dots belong to which cluster. So reassign points closest to a different new cluster center. So which points do you think might be reassigned? So maybe this one, and I don't know which other ones. So the 3 points with the animation, let's see. This one, and this one. Okay? So does everyone understand what we just did? Now what do you suggest we do? Well, we just changed the cluster, the natures of the clusters, right? So what should we do now? We should recalculate the center, right? The center is going to be different now, right? Everyone agree? Okay, so there's going to be a new center, so recompute the cluster means, the cluster centers. Okay, does that make sense? Like that. And now what should we do? Now what should we do? Well, since we just moved the centers, what might have happened? There might be, the points might get assigned to new clusters again, right? Okay, so this is the algorithm, right? So you just keep repeating this over and over again until finally nothing changes. After nothing changes, nothing's going to change forever, right? So you'll have the clusters. Okay, so this is called the k-means algorithm. The reason it's called k-means is because we choose 3 means, so k would be 3 here. Okay, we could have chosen, it's arbitrary how many clusters you want to group it into. We could have decided to start with, to have 4 clusters, but we decided to have 3. Okay, so this is called k-means, where k is the number of clusters that you're going to do. Okay, so using the same idea, you could do the same thing with the whiskey. It doesn't matter if there's 2 dimensions or 20 dimensions. You still can do the same kind of thing. You can't visualize it on a screen, but calculationally you can do the same thing. Okay, so then you can. So this is called clustering. Okay, and this is part of data mining. Okay, all right. So now let's go to Weka, which I showed you before. Weka, right? Okay, so here's Weka, and by the way, on there's a website I have now where I have a bunch of videos on using Weka, and you can use that for the homework. So let's take okay, so let me get some data here. Okay, so this is, oh sorry, this one. Okay, let's look at this data. This is a CSV file. Does everyone know what a CSV file is? What does CSV stand for? CSV. What does CSV stand for? Comma separated values, right? So if I open it up, maybe I'll see comma separated values. Oh, I didn't mean to open it up this way actually. This is going to give us, I won't see comma separated values here, I'll see cells. So what does this data look like? It's got an ID field, an age field, a gender, a region. Region means what? What's this? Inner city, town, rural, suburban, things like that, okay? Income, you can see income. Married, yes, no. Children, how many? Car, yes, no. Savings account, no, yes, so on. Current account, I'm not sure what that means. Mortgage and PEP. I think that's, I'm not sure what that is actually. I'll have to check that later. Okay, so by the way, let's open this up in WordPad just so you can see that it is comma separated. Let's see. Okay, so you can see that it is a comma separated file. All right, now let's try using this data and doing some clustering of this data. Okay, so let's open Weka and open the file, clicking here, and check this box here when you open it. And let's find the data. And I can't see it on this on the desktop. Why not? Because it's checking for a certain type of file down here, and it's not one of those. So I have to choose this. So there it is. Okay, so I click that and click open. Now, do you understand the difference between quantitative data and qualitative data? Quantitative data and qualitative data. Do you understand the difference? What's the difference? Quantitative is numerical data, and qualitative is non-numerical data. How about in this data set that we have? What did I do with it? Let me close this. How about in this data set that I have? What would you say? Is there numerical data here? Is there non-numerical data here? How about age? That's numerical, right? How about sex? It's non-numerical, right? How about region? Non-numerical. How about income? Numerical. Now, if we're going to have some algorithm that's going to do calculations on our data, you can guess that certain algorithms will work with numerical data and won't work with non-numerical data, and vice versa, right? So the nature of the data is sort of important, right? Otherwise, if you don't sort of think about that beforehand, obviously, like you can't add these, right? So if in your algorithm you're doing adding, then it wouldn't make any sense to do it with this. Now how about with the k-means? With the k-means algorithm, were we doing any kind of numeric calculations, do you think? Were there any numeric calculations in the k-means algorithm? Yeah, we calculated the mean, right? So that's definitely numeric calculations, right? So probably if we're going to try to, so what I'm going to do here is I'm going to try and cluster this data. These are people actually that have a mortgage or something. So, um, so I'm going to try and cluster this data. So does it make sense to cluster non-numeric data? Probably not, right? Because we have part of the algorithm is computing means. So it's not exactly straightforward how you would compute the mean of the car, right? The car variable. So I think we should leave that out when we cluster this. Okay? You understand? So let's do that again. Uh, let's open the file here. Actually, I'm not going to click that. And I'm going to do that. Okay, so when I open this, I get all of those variables. So if I want to look at the distribution of age, I can see this. Now, let's not, okay, just ignore the color here. And you can see that this age goes from what? 18 to 67. So there's like a lot of people in this range and less people in this range and so on, right? Okay, so that you can do that with all of these variables. Okay, but I want to try this clustering. So I'm going to click up here, cluster. Oh, sorry. But before I do that, I said what? That I should remove some of the variables, right? So which one should I get rid of? Which one? Let's get rid of all of the non-numeric ones. So which one should I get rid of? Actually, ID is not really numeric, right? Age is numeric. Sex is not numeric. Region is not numeric. Income is numeric. Married is not. Children is not. Car is. Children is. Children is numeric, right? Children is one, two. This number of children. Okay. Car is not. Savings account. The rest of them are not. So let me get rid of those for this clustering exercise. Okay. So let me remove them here. Okay. Now, if you want to undo that, you could just click here, undo. Okay. So now let's go to cluster. And here you have to choose the clustering algorithm that you want to use. So Weka has a number of them. By the way, if any of you are interested in doing a seminar with me or a thesis with me, one thing that I think would be good and interesting is if any of you are good at programming, we can add a new algorithm to Weka. So we can publish it. We can send it to Weka's website, and we can write an algorithm and send it to Weka's website, and it will be added to Weka as one of the algorithms. So I think or we might try and modify one of the existing ones, because Weka is open source software, and so they depend on people doing things like that, and they want people to do things like that, and that would be a very, very good project for a student to do. Okay, but you have to be good at programming in Java, because this is Java's code. Okay, anyway, let's go to here and choose the particular clustering algorithm that we want to use, and the only one that we've learned about so far is this one here called simple k-means. So let's use that one. Okay, and in order to change the options in this algorithm, what you do is you just click on the name of it up here. So if I click on the name of it here, I get this. And the only option I want to change is the number of clusters I want to group this into. Okay, I could leave it at 2, but in the last example that I showed you in the PowerPoint, how many groups did we break it up into? 3. We just did it with 3 in the PowerPoint, right? So anyway, I'm going to break this up, say, into 5 groups. Okay, so what I'm going to be doing is I'm going to be taking all these people and I'm going to be putting them into one of 5 groups. Okay, so let's do that. So let's click OK. And then let's click Start. Hopefully it won't take too long. Okay, it didn't take long at all. It finished. Okay, so let's see what it gave us. So this is the printout that it gave us. So what did it tell? What is it telling me? So let's look at down here. This stuff is nothing. Oh, this tells me that I used 3 inputs: age, income, and children. And I got, how many clusters did I want? 5. I have 1, 2, 3, 4, 5 clusters. And this tells me, by the way, the size of the data set, I didn't tell you that. The size of the data set is, there's about, I thought there was a lot more than that. There's only about 600 in this data set. Okay, so there's 600 people or 600 cases in this data set. And what it did is it broke them up into different groups. Group 1, Group 2, Group 3, Group 4, Group 5. In Group 1 there were 15% of the records are in that group. In Group in Group 0. In Group 1 there were 15%. In Group 2 there were 8%. Group 3 there were 34%. In Group 4 there were 29%. Okay? Now, is there anything we can say about these groups? Well, the way that you sort of find out what are the, now this is a task that someone who's doing marketing might be interested in doing, because maybe you have all of your potential clientele, okay, and you might have a lot of data about each person. Or remember last time I told you about remember last time I told you about the dating site, right? And I told you they have so many variables on each person, right? So let's say they had 1 million people and let's say 500 variables on each person, right? And maybe many of those variables, or some of those variables might be numeric variables. Okay, so what we could do is we could group the people together, right? And so what we're saying is, oh, these people are kind of similar, and these people are kind of similar, and these people are kind of similar, right? By grouping them together like that, right? And the same thing for marketers, right? What they could do is they could take their customers and they could say, oh, well, here's a group of people that are, this is one group of people, this is another group, this is another group. Then the sort of interesting thing for the marketer to do is to try and figure out, well, who are these people? Like, what kind of people are they? Right? All we have is group, 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 but we don't know really anything more than that. Right? So maybe, are these people sort of young women that like sports cars or something like that, right? And are these people, young or middle-aged guys that like to go drinking or something like that? And are these people like young guys that like computers, right? It would be very helpful for marketers to be able to do that, because then they could target their marketing, if they understood what kind of person they were looking at, they could target their marketing to that kind of person, right? Like when you go to a web page, if they sort of know who you are before you come, they'll put up certain kinds of ads there, right? And they don't want to sort of waste that time, right? If you're a guy that's 20 years old, then they don't want to put in, something that middle-aged women are going to be interested in, right? Because you'll just ignore that, and that will be a wasted opportunity for them, right? So they don't want to do that, right? So this is kind of important for in marketing. Okay, this is called market segmentation, which is clustering, right? Segmentation, market segmentation, clustering. Okay, anyway, so we have these groups here, right? We have 5 groups, and how do we know anything about them? Well, the way to know anything about them is to look at, well, here, let's do an example. Let's look at cluster 0. So what, if anything, can we say about cluster 0? We can say that the average, so what this is telling me, by the way, is that the average age in this cluster is what? 28 years. Whereas cluster 1, the average age is what? 51. Whereas cluster 2, the average age is 62. Whereas this one is 30. Whereas this one is 52. Okay? Going back to this cluster 0, what's the average income in cluster 0? 17,000, right? So we 28-year-olds that earn on average $17,000. Whereas here we had 30-year-olds. Oh, these are almost the same. This group is not very different than this group, right? Okay, so maybe it wasn't a good idea to break it down into 5. Maybe we should only break it down into 4, right? Maybe we should merge this group and this group because they're really not much different, at least not according to the first two variables. Okay, what about according to the number of children though? They are different there. Okay, so this group has on average 2.3 children. This group has on average basically no children. So these are like maybe they're not married, right? I didn't include the married variable, but this group might be unmarried. Okay? So we can do this kind of analysis and try and describe the groups. Okay, and once we do that, we can sort of target them in various ways. Okay? All right, let me do one more quick example here, and then I'll quit. So let's see. I also have this data here, and this is an entirely different thing that I'm going to try and do here. So let me show you the data first. So actually this is a project that I'm working on where we're collecting weather data in about 28 different places in the world, and it has to do with climate and growing grapes. So we're collecting various types of data. So you can see that some of the data I have here is the date, which is I converted it to just to a numeric value, and the temperature, and the humidity, and the rainfall, and the pressure, and the wind speed, and the dew point, and this is the gusts. So actually what we were trying to do in this particular project, in this particular situation, was we have these machines that are measuring the weather, and sometimes there's a big gust of wind, and they mess up the machines when you get these gusts of wind, right? They knock them over or whatever. So we were trying to see if we could predict when there's going to be a gust of wind based on these other variables here. Okay? So in other words, based on temperature, humidity, rainfall, pressure, wind speed, and dew point, can we possibly predict when there's a gust of wind? Now this 1 means that there is a gust of wind, and these mean that there was no gust of wind in these times. So this is a certain time, there was no gust of wind. Then this was 30 minutes later actually, and there was no gust of wind, and so on. But here, down here, there was a gust of wind. Okay, so this is the data. This is also comma separated value, and let me just show you one way to go about doing this kind of prediction, or this kind of model, building this kind of model. So going back to Weka, and let's open up that new data set, which is the New Zealand data. And it was all numeric, wasn't it? Yeah, I think it was all numeric data. So if I'm not sure if it was numeric, I can click temperature. Up here is numeric. Humidity was numeric. Yeah, it's all numeric except this one actually. This one is not numeric. I mean, this one is numeric, but I want to change it to non-numeric. So I want to do that because I'll get a different kind of prediction, and I just want to do that. So let me show you how to do that. How to change a variable to non-numeric. Up here you have what's called the filters, and those are just functions that you can apply to the data. So there's a function in there that will change data from numeric to non-numeric. So let me find that function. It's listed in here. It happens to be in here, I think, and in here, I think, and I think it's here. Numeric to nominal is what I want to change it to, I think. Now I sort of forget what I want to do, but I think that's right. So now I have to be careful because this says numeric to nominal first to last. That's wrong. I only want to change the last one to numeric, not all of these. I mean to nominal, not all of these. So I'm just going to change this to last. Let's see if I'll try it now and see if it does what I want. Okay, so let me do that. Now, I have to apply it here. It didn't let me do it. Oh, I spelled it wrong. It's not LL. By the way, another way to do this is, let me do it a different way actually. Which variable is this? This is variable number 8. Okay, so I'll do it like that. Variable number 8. I'll just say that. And apply it. Okay, let's see, did it work? Nominal. Okay, so the gust is nominal. All right, let me show you what's called a neural network. Show you how to use a neural network to make this kind of prediction. And then I'll stop. Neural network is in Weka is listed under the classify tab because classifying and prediction, that's what I'm trying to do. I'm trying to predict or classify whether there's going to be a gust of wind or not. Okay, so it's listed under the classify tab, which is where? Right here. Okay, and then I have to find it, and there's a whole lot of different things that I can do in Weka. So it happens to be under in the list of functions, and it's not called a neural network. In Weka, it's called a multi-layer perceptron. Okay, now let's see if it works. So I'm trying to predict this. Let me try it. Oh, I did the wrong thing. But anyway, it'll probably work. Okay. It worked. It built the model. It's still running down here. So now it's going to test the model. And I'll show you how well it did. So here you can see that it took 8.82 seconds to make this model. Let's see how long it takes to test it. Taking a long time. Okay, I'm going to stop it. I'm going to do something. I'm going to adjust it. I'm going to make it end sooner. So I'm going to change this from 500 to 25. We don't have time to go into what this means, but this shortens the time that it. Oh, that's just the training time actually. I don't need to shorten that actually, but I will. Okay, and I'm going to do something here. I'm going to select that. Let me try it again. All right, it's finished. Okay, so I just built this model and I tested it. And let me find, the last thing I'll do is explain to you, although I'm going to have to explain it very quickly. We would have much more time to explain it normally, but I'll just explain it very quickly how to read the results. Okay, so how well does our model perform in predicting gusts? Okay, so you have something which is called the confusion matrix. It's kind of a weird name for something for it, but what you have here is let's see, this number 393. What that's telling me is that there were 393 cases where there were no. This is what was actually true, and this is what the model predicted up here. So actually true versus what the model predicted. So what does this 393 mean? It means there were 393 cases where it was actually, what row is this in, this 393? Is it in the first row or the second row? It's in the first row. This is the first row, this is the second row. So it's in the first row, so it's in the row where A equals 0, right? So that means there was actually no gust then. And which column is this in? It's in the first column, right? So that means it was predicted also to be no gust. So there are 393 correct predictions there. Okay, how about this one, this 86? Which row is that in? It's in the second row, which means this is what the rows tell you what really happened, and the columns tell you what was predicted by the model. So this is in the bottom row. So there really was a gust, right? Because that's b equals 1 was a gust. And it's in which column? It's in the second column. That means our model also predicted that there was a gust for these cases. So these were also correct. These were correctly predicted as no gust, and these were correctly predicted as gusts. These were wrong. These were actually no gust, but it's in second column, so it was predicted or classified as a gust. Okay, so there were 2 of those, and there were 29 of these. So how well did our model do? Well, it did correct 393 plus 86, and it did incorrect 2 plus 29. Okay, so what's that rate? It's right here. How well did our model do? I have to quit. How well did our model do? It did really well. Amazingly well. 93% accuracy in terms of predicting this. Okay, so this is called classification, and it's different than clustering. And these are 2 of the basic tasks in data mining. I'm sorry I took so long. Let me stop here.